Today, we will be solving one-step equations. Our objective for today is that learners will be able to solve one-step equations with rational numbers. Remember, rational numbers means that we will be including fractions and decimals. If you did not already, please make sure you have the graphic organizer for our equations. At the top, be sure you fill out the "What are you working on" piece and label that with solving one-step equations with rational numbers. Before we begin, we want to do a couple of review items. We want to remember that the main goal for solving equations is isolating the variable. We want the variable to be all by itself. We also want to remember the golden rule for solving equations, or the golden rule of algebra. Do unto one side of the equation what you do to the other. We need to be fair to both sides of our equation. Please take a moment and pause the video and write down the 4 main math operations and their inverse. Yesterday, you took a look at inverse operations, and so hopefully you remember these. Inverse operations are operations that are opposite of one another. So if we are looking at the operation of addition, the opposite or the inverse of addition is subtraction. If we are looking at subtraction, the inverse of subtraction is adding. The inverse of multiplication is dividing. And the inverse of dividing is multiplying. So we want to keep these inverse operations in mind as we solve our one-step equations today. So to quickly review what we learned yesterday, this is a one-step equation. First, we want to identify where the variable is by circling it. To remind ourselves, our goal is to isolate the variable. We want to draw the line on the equal sign to remind us what we do to one side of the equation, we also must do to the other. As I read this equation, I see 4x equals negative 12, and I want to remember that when I see a number next to a variable, there is multiplication in between them. So this is actually 4 times x. I know to solve it, I must use the inverse, so I will be dividing by 4 on both sides. 4 and 4 on the left cancel out to equal 1. So I have 1x, or plain x by itself. And I know that negative 12 divided by 4 is 3. And I want to remember to think about integer rules. Negative 12 divided by positive 4 means I have negative 3 as my answer. I always want to check my work, so I'm going to check 4 times negative 3. Does that equal negative 12? Four times negative 3, 4 times 3 I know is 12. Negative times positive does equal negative, so I do have negative 12 equals negative 12. So now we need to bring in the rational numbers. Please notice this is labeled as example number 1, so you should complete this in the number 1 box on your graphic organizer. When I'm solving equations with rational numbers, my process is the same. I first want to find the variable, and remember that my goal is to isolate that variable. I'm going to draw a line on the equal sign to help myself remember what I do to one side, I do to the other. Now, as I read this equation, I see negative 1/5 x, again, a number next to a variable, so I remember that this is multiplication. The opposite of multiplication is dividing. However, I remember that whenever I divide fractions, I must actually multiply by the reciprocal. So instead of writing divide by 1/5, I am actually going to multiply by the reciprocal 5/1. I do need to make sure that the negative sign carries with that as well. Whatever I do to one side, I must do to the other. So on the right side, I will also multiply by negative 5 over 1. On the left-hand side, the fractions cancel out to equal 1. So I have x left over. On the right-hand side, I must think about my multiplying fractions knowledge. I will put a 1 underneath the 3 and then multiply straight across. 5 times 3 is 15. 1 times 1 is 1. Again, negative times positive gives me a negative 15 over 1 as my answer, which would be the same as negative 15. I always want to be sure to check my work, so I'm going to do that now. Negative 1 over 5 times negative 15 should equal 3. Again, when I multiply fractions, I want to put a 1 underneath and see if I can first cross simplify. I see 5 and 15, those can both be simplified by 5. So now I have negative 1 times negative 3, that does equal positive 3. 1 times 1 is 1. And as we know, 3 over 1 is the same thing as 3. Example number 2. Again, this should go in box number 2 on your graphic organizer. In this problem, I see a plus 1 and 8/11 equals negative 9 and 3/11. I'm first going to remember I need to isolate my variable and separate the two sides of my equation with a line. A plus 1 and 8/11. I see addition, so I need to remember the inverse is subtraction, so I will subtract that mixed number from both sides of my equation. On the left-hand side, positive 1 and 8/11 and negative 1 and 8/11 cancel out, and I have a left over. On the right-hand side, I see negative 9 and 3/11 and negative 1 and 8/11. As both of those are negative, I will actually be adding. So I will first look at my fractions. My fractions already have a common denominator, so I will add the numerators first. 8 plus 3 is 11. My denominator stays the same. Negative 9 plus negative 1 is negative 10. However, as I reflect on my answer, I see negative 10 and 11/11, which means my fraction can simplify. My final answer will be A equals negative 11. To check my answer, I need to plug negative 11 in for the variable in the original problem. Negative 11 plus 1 and 8/11 should equal negative 9 and 3/11. When I am adding or subtracting fractions, I remember I need to have a common denominator. So as I check, I need to find that common denominator, which should be 11. So I will change my negative 11 to negative 10 and 11 over 11, borrowing 1 with that common denominator to solve my problem. Because my denominators are the same, again, I will start with my fractions and look at my numerators. I see that I have a negative 10 and a positive 1, so I will be subtracting. 11 minus 8 equals 3. My denominator remains the same, and then 10 minus 1 gives me negative 9, which does check correctly from my equation. In example number 3, instead of fractions, we see decimals, which are also rational numbers. Again, I'm going to first circle my variable and separate the two sides of my equation. I see negative 5 times f. The opposite or the inverse of times is divide, so I am going to divide by negative 5 on both sides of my equation. Negative 5 divided by negative 5 is 1, so I have just the variable f left over on the left-hand side. 11.5 divided by negative 5. I do not know that off the top of my head, so I'm going to write down my division problem and solve. 11.5 divided by 5. I know that 5 cannot go into 1, but that 5 can go into 11 2 times. 2 times 5 is 10. Subtract and I get 1. Bring down the 5. 5 into 15 is 3. 3 times 5 is 15, which brings me to 0. My answer is not 23, however. I need to remember to bring my decimal up to the top, and my answer is 2.3. In the original problem, I was dividing a negative divided from a positive, so my answer will be negative 2.3. To check my work, I will do negative 2.3 times negative 5. I remember that two negatives equal a positive. 5 times 3 is 15. 5 times 2 is 10, plus 1 is 11. I have one decimal place in my problem, so I need to have 1 in my answer. On your graphic organizer, please find the independent practice number 1 section. At this time, please pause the video and complete these 6 problems. When you have finished these 6 problems, please click resume and check your answers with mine. All right, welcome back. Let's go ahead and check our answers from the independent practice. Numbers 1 and 2. First, starting with number 1, I'm going to start by circling my variable and dividing my problem into 2 parts. I see 3/4 times k, so I know that the opposite is divide, but with fractions, I'm actually going to just multiply by the reciprocal on both sides. On the left, my fractions cancel and I have the variable k. On the right-hand side, I need to multiply my 2 fractions. I can first cross-simplify. 3 can turn into 1 and 6 into 2. And then multiply straight across. 2 times 4 is 8. 1 times 1 is 1, which is the same as k equals 8. I always want to check my answer, so if I do 3/4 times 8, I hopefully will get 6. When I take a look at this, I again can cross-simplify, and I do see 3 times 2 equals 6. Number 2, circle my variable, divide my problem into 2 parts. I see x minus 1/4, so I must add 1/4 to both sides. On the right-hand side, my fractions cancel and I have x left over. However, on the left-hand side, I do need to solve. I do see that I have an addition problem, but that I first need to find a common denominator. I see that 1/4 can be turned into a fraction, an equivalent fraction with a denominator of 20. So I am going to do that. I know that 4 times 5 equals 20, so I'm going to do 1 times 5 equals 5. In my problem, I see that I actually have different signs, so I need to subtract my numerators. 5 minus 1 is 4. My denominator remains 20. I see that 5 over 20 is larger, so that means that my answer should remain positive. However, my answer can be simplified. I can divide both by 4, and my final answer is 1 over 5, or 1/5. I do still need to check my answer and verify that 1/5 minus 1/4 does equal negative 1 over 20. I need to find common denominators once again. 1 over 5 I already had as 4 over 20. 1/4 with a denominator of 20. I know that the 4 is being multiplied by 5, so my numerator is 5. And now I'm doing 5 minus 4, which is in fact negative 1/20. Numbers 3 and 4. Isolate that variable, split my problem in half. I see 4/5 is being multiplied by m, so I am going to multiply by the reciprocal on both sides. The right side it cancels and I have m left over. On the left-hand side, I notice that I have a mixed number times an improper fraction. I must change my mixed number to an improper fraction in order to correctly multiply. 15 times 1 is 15, plus 1 is 16. And that was negative times 5/4. On this multiplication problem, I do see that I can cross-simplify in more than one way. 5 becomes 1 and 15 becomes 3. 4 becomes 1 and 16 becomes 4. 4 times 1 is 4. 3 times 1 is 3. Negative from my first fraction times a positive second fraction will give me a negative answer. I do still want to check my answer. 4/5 times negative 4/3 should give me the correct answer. I do not see any cross simplification that can be done here. 4 times negative 4 is negative 16. 5 times 3 is 15. And when I simplify that improper fraction, I do get negative 1 and 1/15. On the right-hand side, I'm trying to isolate my variable. I see 6.1 times r, so I'm going to divide by 6.1 on both sides. On the right side, those simplify to 1, so I have plain r left over. And now I need to divide fractions on my on my left-hand side. 39.04 divided by 6.1. When I see this, I need to remember how to divide decimals. I need to remember to move my decimal places so that my divisor no longer has a decimal in the middle, and then bring my new decimal up to the top. Now I am looking at 61 into 39. That does not work. 61 into 390. As I look at this, I'm going to think about some simple multiplication facts to help me get close. If I look at the tens place and the first 2 digits in my dividend, I can see that I need to think about 6 into 39. I know 6 times 6 is 36, so I'm going to try 61 times 6. 6 times 1 is 6, and 6 times 6 is 36. I believe that will be the closest that I can come without going over. So I will subtract 366. I need to borrow. And I have 24 left over. I need to bring down the 4. Now I know that 6 into 24, I know that 24 divided by 6 is 4, so I'm going to try 61 times 4. 4 times 1 is 4, and 6 times 4 is 24, and it looks like that will work out evenly. So my answer is r equals 6.4. Now, just like usual, I do want to check that answer. I'm going to erase some work in the middle here so I have the space to do that. I need to do 6.1 times 6.4 in order to check that answer. So I first see 4 times 1 is 4, 4 times 6 is 24. Placeholder 0, 6 times 1 is 6, and 6 times 6 is 36. Add 2 decimal places from my original problem, which means my answer is 39.04, or 39 and 4/100ths, which is the same from my original equation. The last two problems, I still need to isolate my variable and divide my problem in half. I see p minus 4.92, so I will add 4.92 to both sides. On the left-hand side, again, my numbers cancel and I have the variable left over. On the right-hand side, I do see that I lined up my decimals okay. I also see that I have a negative and a positive, so I will actually be subtracting. 2 minus 2 is 0. 8 minus 9 I cannot do, so I must borrow. 18 minus 9 is 9. My decimal comes straight down. 3 minus 4 cannot be done, so I must borrow. 13 minus 4 is 9. In my original problem, I had negative and positive. The negative value was larger, so my answer will be negative. To check my answer, I want to plug it back into the original problem. Negative 9.90 minus 4.92. When they are both negative, I will actually be adding. 0 plus 2 is 0. Is 2. 9 and 9 is 18. 9 plus 4 plus 1 is 14. Bring the decimal straight down and bring down the negative. The last problem, isolating the variable h, dividing my equation into two parts. I see 3.1 times h, so I will be dividing by 3.1 on both sides. On the left, the values cancel and I have h left over. On the right-hand side, negative 7.75 divided by 3.1. I will need to do long division for this. I again need to move the decimal over. (31 into 7 does not work, but 31 into 77 will. 31 times 2 will give me 62. When I subtract, that leaves me with 15. Bring down the 5. If I think about my facts with my 3's, I believe that 3 times 5 would give me that 15, so I'm going to try 31 times 5, which does in fact work out evenly. So h equals 2.5. To check my answer, I need to multiply 3.1 times 2.5. Five times 1 is 5. 5 times 3 is 15. Placeholder 0. 2 times 1 is 2. 2 times 3 is 6. And when I add two decimal places and two decimal places. Now, as I checked, I noticed that I ended up with a positive 7.75, and my answer in my problem was originally negative, and so I need to find where I made a mistake. I noticed that when I divided 7.75 divided by 3.1, I never came back and looked at my signs. So this is actually supposed to be negative 2.5. So for number 6, the answer is h equals negative 2.5. At this time, please turn your paper over and complete independent practice 2. You may pause the video to complete these problems. Here are the level 4 questions. You do need to try the level 4 questions and we will be looking over them. However, they are level 4 and are also a preview into where we will be headed next. When you have finished the level 4 questions, you can turn the graphic organizer into the bin or tray that your teacher has for you. Remember, our objective today was to solve one-step equations with rational numbers.